We are looking at some probability problems. So in this first particular example, notice that they give us a table. It shows the breakdown of 85,000 single parents on active duty in the United States military in a certain year. All numbers are in thousands and rounded to the nearest thousand. So we are to use the data in the table to find the probability that a randomly selected single parent that is in the U.S. military is in the Army. So we are focused on just the Army. They did not care whether they were male or female. So in this case, we will take note that there are 32, and of course that's in thousands, individuals who are in the Army. And that is the total out of the 85,000 total people in the military. And then certainly if you can reduce, you definitely want to reduce. But in this case, this particular fraction does not. So we would say that our answer is 32 out of 85. Now there are lots of different questions that they could ask with that particular table. So for example, if they only wanted to ask you about the number of males who are in the Army, I'd only look at the 23. Or if they wanted to know about the number of females who are in the Air Force, then I could look at 5. Or perhaps they want to just focus on total number of females that are in any branch, then I would be looking at the 22. So just pay attention to which particular part of the table that they are interested in. Now, with my second question, this is something that we call conditional probability because you are given a condition, and with a condition, your sample space gets reduced. So we're looking at a single fair die. Normally, we would say the sample space of a single fair die is 1, 2, 3, 4, 5, or 6. As long as we did not have this statement at the end, that would be the case. But when they tell me, given that it is an even number, my sample space would only include the even numbers on a single die, which would be a 2, 4, and 6. So my sample space for this problem are just those 3 numbers. Now, out of those 3 numbers, they want to know what is the probability that I would actually roll a 2. And so when I look at my sample space, the number 2 only occurs once out of 3 times. All right, with this last particular problem, again, we have a conditional probability because we have been told given that the first is the 10 of hearts. So we've drawn 2 cards from a deck. It says without replacement. So that means once you draw the first card out, you will not put it back. And we're trying to find the probability that the second card is a heart. Now, for those of you who may not play cards, I'm going to bring in a picture of a deck of cards so that we can see. So we are talking about just the hearts here. So these are the hearts in a deck. Notice they just have a picture of a heart on those cards. And so we are looking for the probability that the second card is a heart, given that the first was the 10 of hearts. So the 10 of hearts is right here. What that means is it is no longer in the deck. I have already taken it out because the problem said without replacement. That means I'm not going to put it back. So normally a deck of cards has 52 cards. But since the 10 of hearts has been pulled out, that means there are only 51 cards left in the deck. So that's my sample space. Now, out of those 51 cards, there are 12 hearts that are left. So normally a suit has 13 hearts, but if you've pulled one out already, like we did with the 10 of hearts, then we would only have 12 left. And again, if you can reduce, make sure you reduce your fractions. Both of these numbers are divisible by 3. So 12 divided by 3 would give me a 4. 51 divided by 3 would leave me with 17. So my probability that the second card is a heart, given that the first was the 10 of hearts, would be 4 out of 17.